All right, welcome back.
Oh, Mr. Brandon,
Yes.
is the demo test like the with the question or without the question?
I think it's just a test to see if you can run everything that you need to in that browser. I don't think it's specific to the AP
Oh,
to every AP exam.
oh, I did it, but I did it like 2 days ago, so I thought today we have another demo test.
I think that's it.
Oh, okay.
Okay, so I'm gonna keep going with free response questions. Right now we've got it looks like um, 5 days left of classes for you guys.
Mm-hmm.
Um, before we actually take this thing. So with the time difference, it'll be really early on the 14th, right?
Mm, calculus. Is it 14? I thought it's 13.
We pull it up.
Yeah, it is 13.
I know it's in here somewhere. Okay. Okay.
Oh, yeah.
So, okay, you're right. So it's set for Tuesday, but you're going to be taking it Wednesday really early in the morning. China time, that's
Wednesday.
around 2 in the morning.
Oh, so I should wake up until no, I should be ready at 1:30, like 30 minutes before, and take the test,
Right,
sleep.
right.
Mm.
Okay. And then physics C mechanics is the night before that. But it's going to be 2 hours earlier. So you're starting
So,
at, you need to be ready at 11:30 to go. And your test starts
okay.
midnight. So that's 11:30
Mm-hmm.
p.m. on Monday, May 11th.
Mm-hmm.
Okay. So objectives are the same as last time. We're interpreting derivatives and integrals. We've got fish entering a lake at this rate. They're leaving at LT equals 4 plus 2 raised to the 0.1 t squared. Um, if both are measured in hours, so ET and LT are fish per hour, T is measured in hours since midnight, then I want to know how many fish entered the lake over the 5 hour period from 0 to 5. What do I have to do?
Mm, that's integral fish enter, so integral et dt.
Okay, so we're going to integrate from 0 to 5 of ET dt. Okay. We've got a formula for that, so I'm just going to throw that in.
Mm-hmm.
Okay. Um, we're going to integrate. I'm actually going to throw these in the calculator. I think 20 plus 15 sine pi x over 6. And 4 plus 2 raised to the 0.01 t squared. Okay, so our y1 is entering. I'm going to integrate in terms of x from 0 to 5. Okay, what are my units?
Fish.
Fish. Um, enter the lake from midnight to 5 a.m. Okay, part B. If I want to know the average number of fish that leave the lake, what do I need to do?
That's in 1 over 5 integral LTDT. Integral from 0 to 5.
Okay. We'll do the same thing. Only this will be y2 for us. And then I'm going to divide by 5. That's not what I was expecting to. That's fine. Oh, we got an extra 0 here. Okay, let's try that again. Okay. Units again?
Fish.
Okay, once again, fish. How would you explain what it means, though?
So the average fish that left from 0 to 5 is 0 or about 6 fishes. About 6 fish.
There were 6 fish from 0 to 5, is what you're saying?
Yeah.
Okay, that's not right.
The average fish that left the lake from 0 to 5 is 6.
Still no. That left the lake in the 5-hour period, or left the lake in a smaller period?
5.
Okay, so this is actually the average number of fish that left the lake per hour over the 5-hour period. So that means with a 6 fish average, you would expect about 30 fish over the whole 5 hours. Okay, so this is 6.9 fish on average left the lake per hour. From midnight to 5 p.m. Oh, 5 a.m. Okay, we got the total number of fish here from 0 to 5, and then we divided by 5. So we're only looking at 1 hour, really, not 5. Okay, for part C. If I want to know the greatest number of fish in the lake between 0 and 8, what do I have to do?
Oh, negative ET. Oh, E prime minus L prime should be 0.
That would be the concavity, the acceleration of the fish is 0.
Wait, 0 to, oh, just ET minus LT.
Okay,
It's
so
0.
this is the rate of change of the fish total is ET minus LT, and you've set that equal to 0. Okay. So we'll graph that then. I want to know when y1 minus y2 will equal 0. We only care about from 0 to 8. So I'm going to reduce our window just a little bit.
Yeah, there is 1 point.
Okay, there is 1 point. It looks like it's 1, 2, 3, 4, 5, 6. A little bit more than 6. And we'll calculate. A 0 for a left bound at 4.5 is okay. A right bound I'm going to throw at 8. So that's beyond 6. And my guess will be about 6. That should give us our intersect. Okay, our 0 is 6.2. That was 6.20356. Okay. And then we need to prove that that is a maximum and not a minimum. Let me throw this up again. How can you prove it?
Because it changes from positive to negative.
Okay. As ET minus LT changes from positive to negative.
It's relative maximum.
Six. And okay, so that proves it's a relative maximum. If I want to prove that it is the maximum from 0 to 8, I would need to add another bit to this. So looking at the graph, what else do we need to say to prove that this is the highest point from 0 to 8?
Concavity?
Well, the concavity could help prove that we have a relative maximum. We've got enough to prove it's a relative maximum already. But what more information do I need to prove that this is the absolute maximum?
Oh, end point.
Okay, we could test the start point and the end point. We do actually have another option here, looking at the graph. So what about the graph of ET minus LT tells us that the point we found must be the absolute maximum from 0 to 8?
I don't get it.
Looking at this graph on the calculator, this is ET minus LT. 8 is right here. So if you were looking at this graph, how could you prove that this point where we hit 0 must be not only a relative maximum, but the absolute maximum between 0 and 8?
Oh, because 8 is super negative number.
Okay, so after our point, our slope was negative. So that means we decreased. And before that point, our slope was positive for the whole interval. So that means we increase. So we increase to get to that maximum and then decreased afterwards. So we already know the start point and end point are not going to be the maximum. Okay, so I'm going to write that out. ET minus LT is... I'll work from left to right. Is greater than 0 on the interval from 0... I'll just say before. I should have named this point, that way I wouldn't have to keep writing all that decimal, but ET minus LT is positive from t equals 0 to t equals 6.2. But ET minus LT is negative. For the rest of the interval. So therefore that point is the absolute maximum in the interval. Okay. Any questions on A, B, or C?
No.
Okay, D. I want to know, is the rate of change of the number of fish in the lake increasing or decreasing? And explain the reasoning.
So we have to check E prime minus A prime.
That's right. At 5. So that's E prime 5
Yeah, E prime 5.
minus L prime 5. And we'll get that in the calculator again. Okay, so I've got my difference is negative 10.7228. Okay, now what?
It's decreasing because it's a negative number.
Okay. As E prime 5 minus L prime 5 is less than 0. The rate of change in the number of fish in the lake is decreasing. Okay, awesome. Oh, at t equals 5. Any questions on anything we did?
No.
Okay. So I'm going to have us finish off FRQ numbers 2 and 3 from last year for the homework. These are the most recent questions. I've also sent feedback on WeChat for the previous 2 homeworks free response questions that we did.
Yep.
I think on both of them you scored 8, 9, 8, 9 for the sets of free response that we had. So just take a quick look. I've also sent you the scoring guide so you can see what I'm talking about at the pieces that you missed.
Mm-hmm.
Okay. Anything else you want to talk about?
So we're not going back to school yet, right?
I don't think my answer's changed from last time you asked, but so you saw the message from Miss Martinez, the latest?
Yeah, but she didn't say about the next school date, like when we going back.
Okay, we don't know yet. It's
Oh,
it's not up to the school; it's up to the local government. So my understanding from that letter that went out is that the school did their medical inspection, and the government came back and said we want you to add X, Y, and Z as additional measures that the students will have to take. And so they had to come back again at some point this week in order to prove that X, Y, and Z had been done.
okay.
So once that actually happens, then Ms. Martinez should send out another message letting the parents and teachers and students know what's going on.
Mm-hmm.
So at some point this week, expect another message.
Yep.
All right, anything else?
No.
All right. Hopefully I'll see you sooner rather than later, but we'll see you tomorrow.
Bye bye.
Bye.